Start recording. Yes, okay, great. Okay. Sorry. You see my screen, right?
Yes, we do.
Okay, great. So this is software system design labs. Uh, just a second. Okay, so this is a software system labs. So we are starting. Let me start with the introduction. So basically about me. So my name is Sirajuddin Kamalov. So maybe some of you know me. I am uh, also graduated from Annapolis University, masters, and currently I am doing a PhD here. I've been also doing software development, project management, and machine learning development. So overall, I have 8 years of experience in software development, and I am also top-rated freelancer at work at Upwork, and my main, let's say, technological stack are Android development, web development, requirements engineering, and also machine learning. So, if you have, let's say, any questions or advices regarding these technological stack, please, write me. I I would be happy to, let's say, to answer your questions and help you. Okay, so this is about me, and now let's start about our, let's say, some organizational sides. Let's say, so this is basically the slide from the lecture slides. So it was this is course evaluation, right? So here we are interested in the grading, first of all, right? So this is A start from 90, B start 75, C starts from 60. This also applies to lab, let's say, assessments. And 40% of the overall course evaluation uh, is allocated for lab assignments, right? So this is kind of huge weight for lab assignments, and I hope that you'll be, let's say, more careful with the lab assignments. And we also have lab attendance, right? So this is 5%. So let's start with attendance evaluation. Uh, let's say regulation. So this regulation is by professor, and I think this is by Department of Education. So we have to follow this. So as I said, unfortunately, I am outside of Russia. That's why we're gonna have online uh, labs via Zoom meetings. So, and again, please register into Zoom with your university email before attending the lab, so that your attendance will be automatically marked, right? So otherwise, I don't know who participated, basically. The script doesn't know. And also another requirement is that you have to attend at least 60 minutes, okay? Uh, this means that I'm not gonna call your name to mark your attendance. So uh, after each of the lab, I will just get the report from the Zoom, and the mark will be marked automatically according to your university emails and your Zoom accounts. So they should match. So, and also we will have, let's say, on lab or during the lab, we have quizzes, questions, or we will have problems to solve, such interactive sessions that whenever I call your name, you should respond. I mean, you shouldn't be inactive. So otherwise your attendance will not be counted, right? So you should be active. So this is about attendance evaluation. uh, and lab evaluation, that is 40% of the overall um, grade, right? So as I said earlier, this is a huge weight. That's why I have to explain how you can earn this 40%. So this 40% is basically divided into four assignments. I mean, you can earn by four assignments, three group assignments, and one individual. And their weights are as following. So the first three assignments are group. So the first two is 20 by 20%. The third one is 25%, and the fourth assignment, which has the, let's say, biggest weight, 35%, that is individual assignment. I hope that it will assess your, let's say, knowledge in this course in a more detailed way, right? So that's why this individual assignment has more weight. So okay, this is about lab evaluation. The next uh, thing I would like to introduce is that bonus points. Also, you may earn up to 10% of the, let's say, lab uh, overall lab evaluation. So how you can, by active participation, basically. What does it mean, active participation? This means that solving problems during the lab, solving quizzes. We will have quizzes. So, and again, this 10% is out of 40%. So this is 40% is required, right? So you have to earn, but 10% is out of this 40%. This means that even if you could not earn anything from this 10%, you will not lose overall anything from the overall lab evaluation, right? So this is required, but this is bonus points.
I have a
So
question.
yes,
Is it 4 points for the whole course or 10 points for the whole course?
okay, for the, so it turns out that 4 points for the whole course.
Okay, thank you.
Yeah, if we regard the whole course, but if we regard the lab course, it means that 10% or 10 points. Okay, so communication. Let's consider for now only email. So I am available at this email. I know that Innopolis City is based on Telegram groups. You have a lot of Telegram groups. I do as well. That's why let's not create another Telegram group. And I hope that we will handle our communication by emails. And whenever, if we have something urgent, we will also communicate through representatives, right? So if you have some questions, please send emails. I will try to respond within 1 or 2 days. Okay, about programming language, we will mainly use Java during the lab, but you can also choose Java or Kotlin for the assignments and for the solutions of the problems during the lab. Why Java? Because Java, first of all, supports OOP in a very, let's say, high level. That is basically Java is based on OOP, right? And also Java is kind of one of the most popular languages. And if we stick on only one language, it will be more convenient for all of us to, let's say, to not have any conflicts, right? For example, if I introduce another language such as C++ or Python, some of you might know or uh, might not know. That's why we may have some, let's say, problems. That's why let's stick to Java. Of course, you can also use Kotlin because it's very similar to Java, and I believe that Kotlin is also doing very great job. I mean, in terms of development, clean code, etc. So okay, so this was about introduction, about let's say organizational moments. Do you have any questions?
Can you say what is the size of a group of people for their group assignments?
Well, it will be about 4, from 3 to 5, I can say.
All right, thanks.
Yes, you're welcome.
Will it be the same group for all assignments?
What?
Will it be the same group for all assignments? So like we form a group and we will do all 3 assignments with this group.
Yes, yes. You will form one group and you will do, let's say, all the 3 group assignments within your team, within the team that you chose, that you have chosen in the beginning.
Thanks.
You're welcome. Okay, so there is a question: can we form groups with students from a different group? Okay, I will think about it because we will not. We will start group assignments after about 3 weeks, because as I introduced assignments here, right? So you have only 4 home assignments. So in the beginning, we're not gonna do any assignment. So I will introduce later this assignment, and basically we decreased the number of assignments. The students from the last year, they had, I think, 7 or 8 assignments, but this year I know that university introduced new format of teaching that is in a blocked way, and we have a lot of very intensive lab sessions, right? I mean, course sessions. That's why more assignments would be very difficult for you and for me to handle within a short period of time. That's why I will consider this your question, Mikhail. So I will give you an opportunity to form group. I mean, we will discuss it in the future. Okay. So any questions? You're welcome, Mikhail. Okay, I hope that everything is clear. So, and again, if you have any questions, yes, please send an email, okay? Okay, so we can start our lab sessions. Just a second. So, okay, we're gonna start with UML. I know that you are having, let's say, Professor Zuif started with OOP in the lectures, and he's giving OOP material and resources, right? But we're gonna have a slightly different angle to the course from the labs, I mean, rather than lecture. So we might have some differences in topics with the lecture, but overall, we will cover design patterns and let's say how to effectively design the software systems. So all the materials, I hope they will be useful for you. So first of all, before I start UML, now let me ask you a question. I know that many of you are already programmer. Some of you maybe have been doing some even large projects, are working on the teams, etc. Maybe doing some startups. So, do you remember how did you start? How did you start the project? And what problems did you have and etc. Can you share this experience with us, any of you? Really, has any one of you worked in a project? Or you have, let's say, hobby project? I wouldn't say it you work for a large company and doing some large scale applications, but no, just a simple, you have idea, or you're doing the project for money or for other self or for yourself. Any experience?
Okay, so for example, I had one small project, just funny project. It was a full stack, so backend front end project. I collected the requirements from the person, and after that, I was started. I started from the view from the web page and the functionality. After that, I created the schema for the databases and which tables I need and started. So it was easy.
So did you start right from the coding?
From the paper. I every time just create some main points on the paper, and after that code.
Okay, I see. So anyway, you
That's
didn't.
only because projects are small and really small.
Yes. So, but anyway, you didn't start right from the code, but still you did some analyzing, right? So what does the client need, etc.
Yes.
Right. Okay, great. So yes, thank you, Anna. So so this is we can say that this is correct way, and Maxim says that not everybody wants to follow project structure, and in the end project becomes yes. So basically yes, basically I also started 2 or 3 startups. I mean, I participated at least, and we started right from the coding. I mean, we had an idea. We had to build next Uber, let's say, in Uzbekistan, in Tashkent. Then, okay, what should we do? Okay, let's start the project and we will see. And I was the Android developer, and during the development, I had a lot of questions and unresolved, and I couldn't resolve these questions by myself. I mean, okay, what should be the next screen, or what should I put a button here, or what should happen after pressing this button, and so on, right? So, of course, I was a junior at that time. I had such difficulties. We started the project, then we edited. We let's say introduced a lot of. I mean, we edited the project a lot of times and so on. And in the end, of course, the project failed. And I see now that we didn't, let's say, organize the project properly. I mean, we didn't specify as you did, and we didn't do these things. Okay, what we need from the project? We started right from coding. Okay, right? So basically, This UML modeling that we're going to cover in this session, this allows you to organize your projects, whether this project be your hobby project or some large scale project, in a more effective way, so that it will be easier for you to maintain and develop, extend further. So basically, use case modeling says, okay, use case modeling is about modeling the functionality of a system, right? Okay, if you have some ideas, or in your the client has some ideas in his head, right? So from these ideas, you have to create specifications, requirements, and use case modeling is one of the best ways to do this, because it has well-known and proved specifications and ways to model these ideas into the, let's say, requirements document for the programmer. Okay, so what does it say? So you have to start use case modeling right before the project. I mean, in the requirements phase, if you have some ideas, or a client has some ideas, as we said earlier. So during this phase, you have to do use case modeling, and in the end, you will have what? You will have use case diagrams, right? So this is a long process. So it starts right in the beginning. Okay, now so overall use case diagrams can be considered as a table of contents for the functional requirements of your system. Okay, so if you want to describe your functional requirements, okay, you can show your use case diagram. Okay, these are my functional requirements, and they are showed in a nicely format. Okay, how can we start, or what are the elements of these use case diagrams? Let's introduce actors. So actors are basically stakeholders of the, let's say, of your system. So these are basically user, it can be people, or an external system which has some interaction with your system or project. Okay, so anything interacts with your, let's say, system or project can be considered as actor. So of course, actors has also, let's say, responsibilities when interacting with case diagram, tries to answer these questions. So, but actor, an element of actor, address the question of who and what interacts with the system. Okay, and in our use case diagram, we can represent actor as such icons. I mean, if this is a person, let's say project manager, human resource, operator, system administrator, we can just display it with a stick. I mean, human-like stick, right? Or if it's something such as backup system, right? We see here. We can just draw it inside the box. And also, if we label it as an actor, right here, we have written actor here. So it means that it's understandable for others as well. So, okay, so these are actors. And also we have use cases, which is a description of your functional requirements, right? So let's say you have functional requirements, you describe them by use cases. Of course, use cases also has use case also has actions performed by system or user, right? Or interactions between system and actors. So basically, if actor answers question, if these guys answer questions, who or what interacts with the system. Use cases answer the question how actors interact with the system and describe the actions performed by the system, right? So basically you can represent use cases in your project as follows. Let's say you are working on the project management system, right? So project management system is the title of your whole project, and it consists of several use cases. And let's say 3 of them are manage project, manage resource, and administer system. Okay, so you just you can represent them inside an oval shape. Okay, so these are the use cases. Of course, use cases also itself has some elements, right? For example, here manage project says nothing. I mean, it has, of course, title. You can guess something by its title, but by behavior sequence, you can describe this particular use case. Okay, what should be done in order to perform a specific use case, right? So behavior sequence is also consists of action and interaction. With description. How? For example, let's consider the following use case. Let's say you have login use case in your project, right, or in your system, and behavior sequence can describe this login use case by the following, let's say, sentences. For example, first of all, okay, the system provides a user interface to capture login information. For example, whenever user opens your website, right, the backend sends front-end files such as HTML and others to be displayed in the browser, right? So this is the action performed by the system. Then user enters username, password. It is interaction between the user and system because user enters username and password. Of course, your system should be also able to display these username and passwords, right? Then system validates username and password, and of course, in the end, when authentication or authorization is handled, you should be able to provide correct response to the user, whether he or she was authorized or not, right? So this is basically how you can describe use cases further. So basically, we can think of use cases as an abstract thing, right? Manage project, manage resource, administer system, and here we are describing what each of these use cases can be. Okay, we should also describe the associations, that is, between actor and use case. Actor and use case has some relationship, right? I mean, whenever actor uses our project, we should be able to answer the question, okay, how does actor uses our project? I mean, what part of our project interacts with this, let's say, user, right? So for this, associations answer your questions. For example, here we have several types of associations. For example, in the first example, you see that actor is initiating the interaction with the system, right? You see the arrow directed to the system. Or in the second example, we have system is initiating interaction with the actor. Okay, as an example for this particular sample, we can say that basically all of us has mobile devices, right? And some applications of your mobile devices can send notifications to you, right? So you as an actor are being notified by the system. So here, this system is initiating interaction with you. Then you will open this notification or just swipe left or right to dismiss it, right? And the third type of this association is either system or actor may initiate the interaction. So this is basically unspecified. So interaction might go in a bidirectional way. Okay, so this is we can say that this is the third type of association. Okay, so we have specified associations, and this is how these elements that we described can be put together and describe the whole project, right? For example, we said earlier that let's suppose we are working on the project management system. First of all, of course, you have to identify the actors, project manager, resource manager, system administrator, backup system, right? So these are the actors, and they are interacting with your system within a particular use cases. For example, project manager is managing project and basically is interacting with managed project use case, right? So it has nothing to do with administering system. So basically, administer system is use case is has an interaction with system administrator and backup system and so on, right? So this is how use case diagrams can describe your project. So basically here we have three functional requirements, right? Manage project, administer system, manage resource. And you will describe further in behavior sequence, right? We saw earlier. Okay, so apart from that, we should also introduce dependencies. What does it mean? It means that now let's focus on the left side of the left figure. So any questions?
Yes. May I ask a question?
Yes, sure.
So again, what's the point of having use case diagrams? So I'm starting a project. What will I use the use case diagrams for?
What will use case diagrams for?
Yes. So
Okay, let's go to the first slide. Basically, it's the second slide. Have you ever worked with projects as a programmer? Okay. Okay. How did you start your project?
Well, usually it starts very chaotically, like I am, as a programmer, being thrown a context and like set of requirements, and the manager gives me some initial tasks.
Okay.
So, and like we do a little design and basically start coding. I'm not saying that this is the right way to go. I'm just asking like what will how will use case help me improve the process of the software development?
Okay, so basically in university, when you of course complete the bachelor, you're not just programmer, right? You're not just programmer, right? You should consider yourself as a let's say requirements engineer, project management, etc. So you level up your career, right? That's why university gives you this knowledge. So use case diagram says that okay, so it's so use so Insaf, can you mute yourself? Yes. Okay, basically. So use case says that sorry, just a second. Okay. So use case says okay, so this is basically the job for the ones who are responsible for the project overall. I mean, you said that project manager gave me the some, let's say, task, right? So how your project manager identified these tasks? So this is the question we are trying to explore, we are trying to discover, right? So so this is broader terms of development, where you are responsible for, let's say, converting an idea, converting some, let's say, thoughts in your head or in the client's head to the software product. So we are trying to cover all these, let's say, development phases, and we are starting right from the beginning. Okay, so this is not about coding. So this is, in the end, you will have use case diagrams. So of course there will also be some phases to, let's say, to prepare technical requirements for programmers from this use case modeling. So use case modeling says, okay, first of all, okay, you have an idea. What are the stakeholders of your project? Okay, so we introduced here actors. What, who interacts with your system or project? Maybe, okay, maybe there are users, maybe administrators, maybe operators. First of all, define them. Okay, then define also the parts of your system or project that these particular guys interact with your system. So for example, this is a use case diagram. This is a use case diagram which tries to describe the whole project, of course, in a very poor way. There should be a lot of use cases, a lot of actors, and more, let's say, advanced stuff here, right? So, but this is for illustration purposes. So this is basically the functional requirements described in a more understandable way. Okay, so you can show this to your client. Okay, man, so here we're gonna have 4 actors: project manager, resource manager, system administrator, backup system. We're gonna have 3, let's say, use cases: manage project. We can also describe them in a more detailed way, right? So here by use case instance. So after that, you will have more detailed and description of your system. Of course, after that, you can evaluate your project, right? Okay, we're gonna have these tasks for front end and for back end, and for the front end, maybe these tasks may require, let's say, 100 hours, etc. So you see, so this is in a more, this is the best experience.
Okay, so basically it's just the initial documentation from which everything else is planned.
Yeah, kind of, but this is the way of documentation.
Okay.
Okay, so we will continue. We introduce dependencies, right? So let's consider to this diagram, to the left diagram, right? So let's say we have a requirement of logging everything. I mean, whenever project manager manages project, we should log. I mean, log activity use case should be executed, right? Then whenever system administrator administers system, it should be also logged. Maybe it will do some changes into the system, and it should be also logged and reported in the future. And then the same for resource manager. So you see, log activity, the same, let's say, use case is kind of duplicated for in each of the use case, right? And in a more nicely way, we can, let's say, reformat our, let's say, diagram so that we will separate this log activity. Here you see log activity, right, on the right. And we say that whenever managed project is executed, it should call log activity. Okay, and whenever administer system is executed, it should also call log activity. That is, it should be logged. And the same for manage resource, right? So this include means whenever some use case is executed, it should call another included use case. So it happens every time. Okay, so this is include dependency between, let's say, use cases. So another dependency is extend. What does it say? Now let's consider the left diagram. So here we have project manager, let's say use cases. For example, project manager has use cases such as manage project by maintaining the project itself, right? Or manage project by maintaining an activity, or manage project by maintaining a task. So you see, here we also have a manage project duplicated everywhere, in every use case. So what we can do, we can also make some changes into this diagram and separate manage project, but with extend dependency to other use cases. Basically, what does it say? It says that, okay, project manager manages project in a simple word by either maintaining a project, or maintain an activity, or maintain task. So it says that whenever manage project use case is executed, it will call one of them, or two of them, or all of them. You see, right? So the difference between include and extend is that include calls every time, right? But extend, for example, manage calls one of it doesn't call every time all of the use cases linked to the extend dependency. Okay, so this is extend dependency, and this is how your project or system can be described by use case diagrams. So you see that your functional requirements are now formatted or displayed in a more, let's say, in a more professional way, that what actors are interacting with these use cases, etc. Okay, so of course, in the real project, it's going to be a huge use case diagram, but this is as an illustration, this is a simpler version. So summary, it says that use case diagram can be considered as a table of contents, right? So as a documentation, you can show your diagram to your client or to another responsible people. Okay, we have such functional requirements, and they are used by actors in a following way. And also it also answers the question of what and who interacts with the system, how interacts, etc. So this was about use case diagrams. Do you have any questions? Okay, I hope that everything is clear. We can start the next session. Just a second. Okay. Okay. So the next session is also, we are continuing our UML, and here we have to consider, here we will cover class diagrams. Okay, Let's suppose that after UML modeling, you have defined functional requirements, right? And it's time for what? Coding. But before coding, it's advisable to do these class diagrams, because class diagrams are basically map for the classes of your project, right? Of course, you're gonna have a lot of classes in your project, and they are gonna have, let's say, advanced hierarchy or a very hard relationship within each other. One class might have relationship with one client, or with one class, with many class, one to many, many to one, etc. Right? So class diagrams helps you first map to create a map of these of your classes, so that it's easier for you to, let's say, structure your project, so that if you have let's say several colleagues in your team, it will be easier for you to explain the whole project. Okay, this part of the project, these classes are responsible for that. They are interacting with each other in a such way, etc. Okay, so class diagram basically is a kind of description of your classes and interactions, relationships between them. Okay, basically, if we start from the basic element that is class, right? So it has, of course, class name, attributes, and operations, and we're gonna cover them, cover all of them. First, let's start with the attributes. What are the attributes of a class? These are basically variables or properties in programming language of a class, right? So it has visibility, name, multiplicity, ordering, type, initial value, etc. Okay, so if we cover each of these components separately, for example, if we start with visibility, we know that the attribute or variable can be public, private, protected, etc. Right? But UML supports three types of visibility. That is a public visibility plus private visibility minus or protected visibility. You can represent it as sharp, right? Sharp sign. So this is visibility. Then you should also give proper name for your, let's say, variable or your attribute, so that it has meaningful. It describes its responsibilities, right? And it's if your variable contains more than one values, you should also specify in multiplicity, let's say, parameter. For example, it may contain one by default or from 0 to infinite, such as arrays, lists, etc. Right? And if your attribute or variable can contain more than one variable, you should also specify ordering. By default, unordered, of course, you can also specify that the values of this attribute should be ordered. Then type, of course, we know that variables may have several types, and it's different for each of the programming language, right? But UML supports four types of attributes. These are Boolean, integer, real, and string. And initial value, you can also specify initial value. If your attribute is static, you can also display by underlining it. Okay, for example, in the bottom you see that this let's say attribute, class attribute, described in a in a UML way. For example, we see that it has private visibility, its name. Okay, it can contain up to 5 value in unordered way. Its type is string, and default value is no email address, right? So the next element of the class is operations. This is basically a method or function, right, in programming language. So it has also specifications to be let's say displayed in a UML diagram. For example, you have to specify visibility, name, parameter list, and return type. Visibility, we covered public, private, or protected, right? And name of the method or function, right? And return type. What does it return? Or if it doesn't return nothing, it's void, right? Void function or method. And parameter list. Okay, method or function in programming language, we know that it can consume parameters, right? So here is a specification for UML that you have to describe the parameters. For example, first of all, you have to describe the kind. It can be, of course, optional. The default value is in. In means you are passing this variable directly. Out means you are not passing this variable directly, but it will be modified, this parameter. In out means this parameter is being passed directly, and it will be modified by the method. Okay, so basically this is the method or function, or in UML diagram you can call it as operation, how you can describe it. So plus we see that it's visible publicly. This is the name of the operation method, or let's say function, right? So here we have a parameters, right? So it has in kind, which means that it is passed directly and it's not modified, right? So the name of this parameter is the email address, string, default value is this empty string, right? And your function or method should return Boolean. Okay, so this is how you can describe your function or method in UML, let's say, language. Okay, so basically this is how you can put everything together that we talked about in earlier slides, right? So here we have, let's say, a work product, name. These are the properties in a specified way, and these are the functions and methods. Okay, so this is how a single class can be represented.
Excuse me,
but we know.
Can I ask
Yes.
a question?
Yes.
So we have kind in, out, and in out, but like in the parameter lists in the examples, in is lowercase, but in the kind is optional, is like can be like in starts with a capital letter. And how do we write in out? Like how do we write in out? We'll write it like with underscore between in and out, or we just
well, I think it depends on the UML editor or UML preprocessor. So okay, in out, I think it's capital. So let me write this question. Capital. Okay. So I will answer you later. Okay. To be honest, in out and in out, they are kind of. We know that in programming language, they are not very popular, right? So that's why I didn't have experience working with them, but I will answer you. Okay.
Okay, thanks.
You're welcome. Okay, so let's continue. Okay, so we here covered the elements of a single class, right? But we know that our project uh, consists of several many classes, right? And they also have a link it to each other in a different way. We say um, one class can be uh, may have a relationship with many classes. It may use another classes, or it may be used by another classes, etc. Right? So here we introduce associations, which tries to explain relationship between classes. Okay, so let's consider the following case. For example, here we have uh, three classes, right? Work, work product, and unit of work. And by these direct lines, you can uh, introduce relationship between these classes, and binary association means that both of the classes can have an access to each other. I mean, they know each other basically, and you can also describe the relationship. For example, worker is responsible for work product, right? Or um, unit of work consume as input work product, or unit of work produces as output work product, etc. Right? So this is we are defining the relationship between classes, and we can also describe the association ends. Basically, this is uh, association ends. In associations ends, you can also describe the how many instances can be linked to a class. For example, here we see that one worker class can be linked to many from 0 to infinite work product classes, right? And here we see that this is not a binary class association anymore. That is, worker is using work product, right? Uh, and you can also describe this relationship. For example, the work product, that is work. So worker and work product is the relationship between them is described as a work product, right? Or work product is an input for unit of work, and so on. So this is how association ends can give some more details about relationships, such as um, number of instances linked together, or some more information, right? Okay, so now this is navigation. Navigation basically, it's basically this is an optional. So as we said earlier, this says that which class is using another class. For example, worker and work product. So here we have an arrow, right, directed to the work product. So this means that worker is using work product, and work product does knows nothing about worker. So this is navigation. Multiplicity we talked about. For example, one worker may have a link to many work products, and so on. We should association can also be to get define it further. For this illustration, let me share another screen. Just a second. just a second. Yes. This. So basically, we saw that multiple classes can have relationship, right? So it can be described or it can be displayed as association, and we can also have a composition. Let's say relationship. What does it mean? It means that, let's say we are working on a project which we have to model human body, right? Okay, we have person class, and we also have head, hand, and leg classes. And these classes here, head, hand, and leg, can all must be also used by person, right? Should be, it must be only linked to person. It can't be used, let's say, by other classes. If we have some animal classes or some, let's say, robotic classes, right? So this head, hand, leg only for person classes. But aggregation says no. Aggregation says, okay, one class can be used by several types of classes. For example, engine class can be used by car, and also engine inspection, right? To do some inspection, to do some monitor. And wheel also can be used by car, and also um, another class. So this is basically two types of, let's say, association types. So what you have to remember. Now let's back to uh, our our presentation. So we defined association, aggregation, and composition, right? So you can also introduce types and interfaces in the UML. Types means that type might have attributes and associations, but doesn't have any method, right? Okay, and the type can be represented by the figure on the left, right? And you should label them as type. An interface, as an opposite, it cannot contain any attribute or associations, but it may contain operations, right? Or method or functions, right? And you can display, or you can label them as interface, your let's say interfaces in UML. And we also have generalization. Basically, this is how inheritance work. For example, let's say we have worker. Human resource extends a worker and inherits this class. Then we have resource manager and so on, right? So this is basically how you can describe the inheritance between your classes. So basically, this is how we put everything together, how one project can be, let's say, displayed as a relationship between classes, and every class you see has its own parameters, methods, and so on. So in the assignments, we will work with UML, especially one of your requirements will be provide an UML version of your classes. So they are very helpful, not even for your assignments only, but overall in industry also they are used. I know that there are tools that if you define the UML representation of your classes, they can generate classes for your projects. I know such tools exist for Java. So this stuff is kind of useful. So as a summary, we can say that with class diagrams, you can describe your class attributes in a detailed way. And of course, the relationship between classes in a specified ways. Okay, so do you have any questions? So this is basically UML.
So how did you personally use the class diagram in your experience?
Okay, mainly I used in one of the thesis works as well, of course. Then in industry, I used to understand um, the structure of the library. You know that IntelliJ IDEA, if you have worked in Java or in Kotlin, it has a feature called generate UML, and you will just show the path or library or the package to the IntelliJ IDEA, and it will analyze and it will generate such class diagram. And after that, I had some, let's say, better intuition. Okay, what classes are working to each other? Which class is which class is the super class of this class, and so on. So because the library was kind of very big, it was very, I think there was no documentation, so I had to figure out everything, how to work with this library. So for this particular example, it helped me. And of course, if you work in some large companies, I believe that they work because you have to prove your work for the upper management.
Okay, makes sense. Thank you.
You're welcome. So any questions? Okay, if no questions, we can go to the final session of our lab. Just a second. Okay, you see my screen, right?
Yes.
Yes.
Okay, great. So as I said, I will try to give an opportunity to earn these bonus points for you. So every lecture. So we're gonna start our QA session. Just a second. Yes, so we're gonna play some game. This is basically who wants to be a millionaire. So you will answer questions. I will let's say ask from any of you, and you should answer the questions. If you answer, you will earn the point. If not, if you couldn't answer, no. So this is the first question. Just a second. Okay, let's start with Timur Lysenko. Please, can you answer this question?
Okay.
What type of correlationship is represented?
Okay. Looks like aggregation. I don't quite remember.
So aggregation,
Yes, yes.
maybe dependency.
Okay, I honestly don't remember.
So please choose any of them.
Okay, I choose aggregation.
So yes, you're correct. And Timur earns a point. Just a second.
Yay.
Yes, Timur. So the next question, okay. Let's ask from Anna. What type of relationship is represented by the symbol in the figure below? Anna, I hope that there is one Anna, right?
I think yes.
Okay, so can you answer this question?
I think it's composition. Am I right or not?
Okay. Are you sure? Is this your final answer?
Yes.
Okay, let's try. Yes, you're right.
Oh, well.
Okay, you also earned some points. Now let's go to the next question. And the next question, sorry. Okay. Insaf, are you here?
Yes.
Okay, great. So can you answer what type of relationship is represented here?
Generalization.
Generalization. Are you sure?
Yeah, I want to try this answer.
Maybe dependency.
Let's try generalization.
Okay, great. Yes. Insaf also earns a point. And even for this particular question, let's ask Alisa Martianova. Are you here?
Yes.
Okay, Alisa, can you answer? Let's say we're gonna implement this particular, let's say, relationship in programming language. For example, in your favorite language, what relationship it can be?
Like inheritance?
Yes.
I mean, like a square can implement some interface shape class, and triangle can implement some interface shape class.
Yes, you're correct. Alisa also earned some points. Thank you, Alisa. Okay, so the next question. Let's ask from Daniel. Daniel, are you here? Do we have one Daniel or?
Yeah, I'm here. Probably.
Hi, Daniel. Okay, what do you think? What in class diagram, the public visibility of attributes is indicated by which symbol?
Public visibility.
Minus, plus, sharp, or asterisk?
I'll go with plus for public.
Are you sure? I will give you one more attempt.
I might be wrong, but I don't doubt my choice.
Okay, great. So this was correct. So this plus is indicates public. Thank you, Daniel, for your participation. Okay, here we have Maxim Stepanov. Are you here?
Yes, I'm here.
Okay, can you answer the next question, please?
Protected is denoted by sharp.
Oh, great, Great. Thank you. Yes, that's correct. Protected is denoted by sharp symbol. And do we have Alina Zavidova here?
Yes, it's me.
Hello, Alina. Can you answer this question?
1 second. So the actor initiates the interaction with the system D.
The actor initiates the interaction with the system. So system cannot send notification to actor?
I choose D.
You choose simply D, right?
Yes.
Okay, great. So this is the power of this. Yes, you're correct. So D is correct. Thank you, Alina. So the next question, let's ask from, who do we have? Jamil. Jamil, are you here?
Yes, I'm here. Can you hear me?
Yes, sure. We can hear you. What do you think about this question?
A, actor cannot reach the system.
Okay, but this is incorrect, Jamil.
Okay, if it's not correct, it should be B.
Let's ask from someone, Jamil. You lost your attempt. Let's ask from.
You haven't given him the second attempt.
But yes, you're correct. But it's I hold the responsibility or opportunity to give an attempt or not. So let's ask from Idil. Idil, are you here?
Yes, I am. So the same
So
question.
I will ask. Yes, and I will also ask one more question regarding this, so it will be more fair. So the first question, describe the process below.
So it's B, either the system or the actor may initiate the interaction.
Okay, so then imagine the following situation. Okay, so let's say you are ordering a taxi. So let's imagine that this is the project. This is a use case. You are searching for the taxi, and taxi couldn't be found. I mean, let's say you chose economy class. Let's say. And a taxi couldn't be found nearby you. So can this process be described by this, let's say, by this shape?
So let me think. So I think yes, because if I understood you correctly, so I'm looking for a taxi, so the app can initiate interaction with me when the app will find a taxi. So yes, it is okay.
Yes, you're correct. You're correct. Sorry, you're Jamil, right?
No, I'm Idel.
Idel. Sorry. Yes, Idel. Thank you for your answer. Okay. Yes, you earned the point. So let's ask from Kirill. Are you here, Kirill?
Yes, I'm here.
So what do you think about this question?
So it should be C, relationship between classes.
Okay. Yes, you're correct. The answer is C, relationship between classes. Yes. Thank you, Kirill, for your participation. Okay. For this, sorry, Jandos, are you here?
Yes, I'm here.
So what do you think? Can you answer this question?
I suppose that's the all the answer, correct?
So the answer is yes. Association can be binary, unary, or any array. So thank you for your answer. Quiz is over. Unfortunately, I have such number of questions. If you have questions, please ask. I mean, about anything. So about the material, if you have questions, or about organizational process. And by the way, tomorrow we do not have classes, right? If you remember, so we moved it to Friday, Friday 9 a.m. So I know that some of you have electives at that day, or you didn't plan for that. So that's why on Friday we're not gonna count attendance. I mean, it means that you all of you will be counted as attended. So even if you could not attend, don't worry about your attendance. The lab will be recorded anyway, so you can watch it later. So any questions, please?
I have a question. So
yes,
where can we track our attendance?
Well, I will try to upload it on the Moodle, but not every week. I mean, sometimes I will just get the report for several sessions, right? Then run the script so that it's easier for me. That's why you can see it on the Moodle. If you have any questions, if you think that your attendance is wrong, you can reach me by email, of course.
By the way, I have another question. So for attendance, we have a point that we have to attend at least 60 minutes per lab. So if I don't have stable connection, and if I'm out and I will reconnect, will it count or not?
Well, in that case, please write me. I mean, state your reason. Why couldn't you attend 60 minutes? Then, okay, why not? It's not a problem.
Okay.
You're welcome. So, any questions? Okay, if so, guys, thank you for your participation. Today's lab is over, and I will see you on Friday. Thank you.
Goodbye.
Thank you. Goodbye.
Goodbye.
Bye. Bye. Bye.